Welcome to my channel, where we boldly go where no one has gone before. Today we're delving into the thrilling concept of faster-than-light travel. Just imagine traversing the vast cosmic gulfs, hopping from one star system to another, as effortlessly as we navigate our own planet. It's a concept that has tantalized scientists, science fiction writers, and dreamers for generations. Let's soar beyond the limits of conventional physics and explore the frontiers of interstellar travel. For centuries, the speed of light, a staggering 299,792,458 meters per second, has stood as the ultimate cosmic speed limit. It's the bedrock of Einstein's theory of relativity, dictating that nothing can travel faster than light in the vacuum of space. But what if there are loopholes in the very fabric of space-time itself? Theoretical physicists have proposed concepts like warp drives and wormholes. Imagine warping the fabric of space-time, creating a localized bubble where the very notion of distance shrinks. A warp drive wouldn't propel a spacecraft through space in the conventional sense, but rather it would manipulate space itself, allowing us to cheat the cosmic speed limit. Wormholes offer a different kind of shortcut, threading through the very fabric of space-time, connecting two distant points in the universe. Dive into one end of a wormhole and you could emerge light years away in the blink of a cosmic eye. The sheer energy requirements to create these space-time distortions are mind-boggling, dwarfing even the output of our most powerful nuclear reactors. And then there's the issue of stability. Could we create a wormhole that wouldn't collapse upon itself the instant it formed? The challenges of faster-than-light travel are immense, perhaps even insurmountable. Yet the pursuit of these ideas pushes the boundaries of human ingenuity, forcing us to confront the deepest mysteries of the cosmos. The prospect of faster-than-light travel opens up a universe of possibilities. Imagine a future where humanity is no longer confined to our pale blue dot, where the stars themselves become our backyard. Interstellar colonization, once relegated to the realm of science fiction, could become a tangible reality. With faster-than-light travel, we could reach distant star systems in a human lifetime, establishing outposts of civilization on planets orbiting alien suns. Picture children, born on distant worlds, gazing up at a night sky, not with the familiar constellations of our own, but with the majestic tapestry of a truly alien sky. The galaxy becomes our canvas, ripe for exploration and discovery. Imagine vast interstellar expeditions charting the unknown regions of the Milky Way, encountering new life forms, new civilizations, perhaps even unlocking the secrets of the universe's birth. But interstellar colonization wouldn't be without its challenges. The distances involved, even with faster-than-light travel, would be immense. Communication with Earth would be delayed, perhaps by years, forcing these intrepid colonists to forge their own destinies, independent of their home world. Encountering alien life, perhaps even intelligent life, would forever change our place in the cosmos. Would we approach these new worlds with a spirit of cooperation, or with the same impulses that have so often led to conflict in our own history? Faster-than-light travel doesn't just challenge our understanding of space, it upends our very notion of time. One of the most mind-bending consequences of Einstein's theory of relativity is time dilation, the idea that time is not absolute, but rather, it flows at different rates depending on your relative motion. Imagine a spacecraft traveling at a significant fraction of the speed of light. For the astronauts on board, time would seem to pass normally, but back on Earth, time would be ticking by much faster. The astronauts could return home after what seemed to them like a few years, to find that decades, perhaps even centuries, had passed on Earth. They would have effectively traveled into the future. But faster-than-light travel introduces even more bizarre possibilities. What if we could travel faster than the speed of light? Wouldn't that mean, at least theoretically, that we could travel backward in time? Imagine meeting your past self, perhaps even influencing the events of your own past. The paradoxes are endless and seemingly insurmountable. Could you, for instance, go back in time and prevent your own birth? If we ever do achieve faster-than-light travel, we may well unlock the secrets of time travel as well, but we would do well to tread carefully. The river of time, once thought to flow in only one direction, may prove to be far more complex and treacherous than we ever imagined. The search for exoplanets, planets orbiting other stars, has been one of the most exciting frontiers in astronomy. With telescopes like Kepler and TESS, we've discovered thousands of these distant worlds, some eerily similar to our own, others stranger than anything we could have imagined. The sheer diversity of exoplanets is a testament to the universe's boundless capacity for creativity. But among this cosmic menagerie, the holy grail of exoplanet research is the discovery of a truly Earth-like world, a planet with liquid water on its surface, a breathable atmosphere, and perhaps, just perhaps, life as we know it. And with faster-than-light travel, the possibility of reaching these distant worlds and answering the age-old question, are we alone in the universe, becomes tantalizingly within reach. Imagine landing on an alien world, feeling the pull of gravity under an alien sky, breathing air that's both familiar and strange. The prospect of alien contact is both exhilarating and daunting. It holds the potential to reshape our understanding of ourselves, our place in the cosmos, and the very meaning of life itself. As tantalizing as the prospect of faster-than-light travel may be, the technological hurdles are immense, perhaps even insurmountable with our current understanding of physics. Warp drives, wormholes, these aren't just engineering challenges. They require bending the very fabric of space-time itself. To even begin to contemplate such feats, we need breakthroughs in our understanding of exotic matter, hypothetical particles with negative mass energy density that could, theoretically, warp space-time in the ways we need. Then there's the issue of energy. The energy requirements to create a warp bubble or hold a wormhole open would be astronomical, dwarfing the total energy output of our civilization by orders of magnitude. We're talking about harnessing the power of stars, perhaps even black holes, if we're to even dream of such endeavors. But let's not mistake technological limitations for impossibility. Human ingenuity has a remarkable track record of defying expectations. Consider, for instance, that just over a century ago, powered flight was considered a pipe dream. And yet, here we are, launching rockets into space, exploring other planets with robotic emissaries. Breakthroughs in fields like quantum physics, materials science, and energy production could pave the way for technologies we can scarcely imagine today. Fusion power, for instance, could provide us with the energy densities needed for interstellar travel. The journey towards faster-than-light travel may be long and arduous, but it's a journey worth undertaking. The pursuit of faster-than-light travel isn't just a scientific or technological endeavor. It's a profound philosophical and ethical undertaking. As we stand on the precipice of the cosmos, poised to potentially encounter other intelligent life forms, we must ask ourselves some hard questions. What are our responsibilities to the life forms we may encounter? Do we have the right to impose our presence on their worlds, to potentially disrupt their ecosystems or their cultures? Or should we adopt a policy of strict non-interference, observing from a distance, respecting their right to exist undisturbed? And what about the potential for conflict? Human history is rife with examples of conflict and exploitation, often driven by the perception of difference or the pursuit of resources. How can we ensure that our first contact with an alien civilization doesn't devolve into a cosmic misunderstanding, or worse, a catastrophic war? These are questions that require careful consideration, not just by scientists and engineers, but by philosophers, ethicists, and policymakers. The decisions we make today, as we stand at the cusp of the cosmos, will shape the future of humanity among the stars. Imagine a future where humanity has achieved faster-than-light travel, where we've established contact with other intelligent species, where the stars themselves are no longer a barrier, but a bridge to new worlds and new perspectives. The societal impacts of such a paradigm shift would be nothing short of transformative. The very notion of nation-states, bound by the limitations of geography, could dissolve in the face of a shared galactic identity. We might see the emergence of a global civilization, united by our common humanity and our shared destiny among the stars. The exchange of knowledge and culture with alien civilizations could usher in a new renaissance, a flourishing of art, science, and technology that dwarfs anything in human history. The challenges we face here on Earth, climate change, poverty, disease, could pale in comparison to the opportunities and challenges of a galactic civilization. But perhaps the most profound impact of all would be the humbling realization that we are not alone, that our little blue planet is just one tiny speck in a vast and ancient cosmos teeming with life and intelligence. As we venture further into the cosmos, driven by our insatiable curiosity and our yearning to understand our place in the universe, we're bound to encounter mysteries that challenge our very understanding of reality. The vastness of space and the depths of time hold secrets that we can only begin to imagine. What is the nature of dark matter and dark energy, the mysterious substances that make up the vast majority of the universe's mass energy budget? Are there dimensions beyond our own, realms of reality that we can scarcely comprehend with our limited senses and instruments? And what about the ultimate fate of the universe itself? Will it expand forever, growing colder and darker with each passing eon? Or will it eventually collapse upon itself in a fiery big crunch, only to be reborn in another Big Bang, an endless cycle of creation and destruction? But with faster-than-light travel, we could potentially access data from the far reaches of the cosmos, unlocking clues to the universe's deepest secrets. We might even encounter civilizations far older and wiser than our own, civilizations that have grappled with these existential questions for millions, perhaps even billions of years. The pursuit of knowledge is an endless journey, and the cosmos is the ultimate frontier. The dream of faster-than-light travel ignites our imagination and propels us toward the stars. It's a dream fueled by our innate curiosity, our thirst for adventure, and our yearning to understand our place in the cosmos. While the challenges are immense, the potential rewards are even greater, promising a future where humanity transcends the limitations of our pale blue dot and sets out to explore the boundless wonders of the universe. If you found this exploration inspiring, please like, comment, and subscribe for more captivating content. Your support helps us to keep exploring the big questions, the mind-bending mysteries, and the awe-inspiring wonders of the universe we inhabit.